Our first session in the industrial track is an industry keynote on defending cyber physical networks. To present this, we have Colonel Dr. Indrajit Singh, Chief Cybersecurity Officer, Vara Technology, India.
I'm Colonel Inderjeet Singh, and I'm going to be talking of a very pertinent topic on the cyber physical networks and how do we really defend them. Just as a prelude, last couple of years have been really very alarming when we are seeing so many cyber attacks hitting the OT networks and really causing disruption to the level that it is causing effect to the human beings, the population. And defending them at the same time is of paramount importance to us. And what has been seen is in the last couple of years, there have been large number of cybersecurity incidents on the operational technology networks, the OT networks. And these attacks were at a cost, whether it was a shipping and logistics, where the operations were disrupted for almost 2 weeks, metal and mining, refining sector, your manufacturing area, your pharmaceutical, and all these cyber attacks not only costed too huge for the companies, for the organizations, and for the government, it also caused disruption for a number of days because the complete systems were being shut down for quite a number of days and they had the inability to fulfill the requirements of the organizations or the government. And there was loss of sales, there's a loss of business, loss of operations disruption, and a lot more. So the cyber attack on the OT networks is a real point of concern right now and most talked after point in any discussions where we are talking of the OT security. Added to this is we are seeing the Internet of Things, which is almost going to be 75 billion devices by 2025, as per one of the studies. We're also seeing the industrial IoT, and it has revolutionized the complete industry where every industry is actually getting into the IIoT 4.0. It's giving them transparency, it's giving them predictive maintenance, it's giving them remote monitoring, it's improving the services, the enterprise kind of connected enterprises which are coming up. It's really changing the whole ambit of the smart factories which are coming up in due course of time, and it's really revolutionizing the way we are living, the way we are going to be doing business, the way we are manufacturing, and a real merger of IT and the OT. We've been talking of the IT for quite a number of years, where we have been talking of the information, the data, which was very important. And now, with the advent of the Industrial 4.0, we're talking of the cyber physical systems and the OT security, all about the operations. That is how we are seeing the fourth industrial revolution actually changing the whole ambit of the security, the way we do the business. Earlier we've been talking of the security or the cyber security. Now we are going to be talking of the IoT security. The transactions which are all centralized repository, we are all talking of the blockchain based transactions. We're bringing in so much of transparency in the network. Your interfaces were all buttons, and today we are talking of the voice and the gestures. Decision making were all data and the spreadsheets, and today's all AI, machine learning, deep learning. And where we had the mobility as one of the drivers, we are talking of the autonomous systems and the factories which were being run by humans. We are all talking of robots running the factories. And that's where the smart factories are all coming in. It's all a network of intelligent objects, where earlier, when we are seeing today as Industry 3.0, it was machine plus the software, right? And that's how we were building up the softwares to run the machine. And there's a paradigm change which we are seeing with the Industrial 4.0, which is software plus the machines. And that's where we are talking of advanced manufacturing and the intelligence which you are building out in the system. And it's all about the sensors and the actuators, which are actually moving on the software data bus, and thereafter we have the UI, the human machine interfaces, and then going on to the cloud, right? And which is creating a system of systems connectivity, and it's basically creating intelligent systems in the cloud. That's what is the autonomous IIoT systems going to be in due course of time. And this IIoT systems is across every sector, whether it's oil and gas, pharma, power, food and beverages, wastewater, nuclear plants, water, transportation, chemical, name a sector, it is. It's all there, having the usage which we are finding out. And the Industrial 4.0 has got three major areas which we've been talking of. Everybody talks of the Internet of Things. We have been talking of communicating objects based on the internet technologies, IPv6, right? And now we are talking of Internet of Services, which is a new approach to provide internet-based services for your smart logistics, your smart production, your smart engineering. And it's all about the interaction between people, machines, systems to improve added value. And it's all about the service-based added value processes. And then it's the Internet of Data, where the data is managed and shared using the internet technologies, and you primarily manage big data and you integrate product and the production data together, and the cyber physical system are producing so much amount of big data. How do you really handle that? And that's one of the fundamental requisite to development of a holistic security and the safety culture in any organization for that matter. Coming on to the traditional factories, what we are seeing, the monolithic factory systems, we had fixed locations, it was hierarchical, it was all wired. We never knew where the devices were, where the product solutions were, unknown positions. And we had the PLCs, which are running the show, and it used to take quite a number of time connected to SCADA. But what's changing? With Industrial 4.0, we are looking in for the shorter product cycle. We are looking into the individualized products, international competition, quality demands we are getting onto, and that's where we're getting onto the wireless system, location sensing, context-aware devices, context-aware systems. You're changing locations from a monolithic, we are getting onto the modular system, and from the hierarchical, we are all there as a distributed environment, right? And it gives you the power of information and communication technology connected to SCADA. So just see how the systems are changing with the advent of the IIoT 4.0, and the whole lot of things are getting onto. And each object today is being treated as an abstract object, and it's got an intelligence, it's got a unique identity, which is IPv6 based, it's got an RFID, it senses, it tells you where it is, and it offers autonomy. And it also, you're able to locate where it is in the manufacturing bay all the time. And it's got a very standardized network interfaces. You know what you need to do, how they've been connected, whether it's a OPC UA or whether it's a OPC DA. You know it all, and it's been described by models. This is how you're actually getting in the intelligence inbuilt in the complete manufacturing process, which was never there earlier. And this is the power of IIoT 4.0. And this is where we are actually looking in so much from the manufacturing industries, which are moving way ahead. But at the same time, if you look at it, there are lots of outward and the inward data which is coming in. And when we talk of the outward, there's so much of hyperconnectivity. There are devices everywhere, there are networks everywhere, there are information everywhere, automation everywhere, distributed data, logic and views everywhere, remote connections, remote monitoring everywhere, and logic control. And when you have an inward looking part of it, you see it's an IT-OT convergence, intelligent sensors, technology unification, supplier rationalization, support harmonization, hybrid roles, expanding responsibility, and centralized view. So just see the amount of information which you are having both outward and inward because of the IIoT. And just to give you a difference between the OT technology and the information technology, You know, generally what we all talk of it, that the IT is around 3 to 5 years of economic span. You have a standardized systems, we all know it. We are all recovery focuses on data and system performance. And we talk of the CIA, that's the confidentiality, integrity, and the availability of the system, right? And when we talk of the OT, it's the kinetic cyber consequences. It's a critical information infrastructure. Any damage to it would cause the life, damages, which is all there, and it can affect, safety. The lifespan of the OT technology is really very long. It's around 15 to 20 years. Often outdated proprietary or special softwares and protocols. It's very difficult to change all of them, and the safety processes and the environment is the most important factor when we talk of the OT technology. Now, it brings in the new risk when we talk of the cyber physical system. And I spoke of the IT and the OT convergence. It is very important to discuss because it's IT and the OT are so converged that OT networks are no longer, separable. And the threats move between the cyber and the physical dimensions, transparently. That's a basic challenge what we are finding. And the assets are highly critical and really can be patched in this kind of environment because you're so much exposed because of the cloud computing which is coming up, the OT security which is there. So it's a complete merged network, converged network. So it's a very difficult proposition. And the threats are targeting on the non-traditional devices, and they're targeting on the IoT and the OT, which is really very much growing. Sophisticated actors are developing new attacks vectors. They know how to attack you. They attack with the 0 days. You're taken aback by whatever is happening, and you really have a limited ability to remediate these threats in a real time, unless and until you really take corrective measures for this purpose. So the cyber risk is resulting in an operational and safety risk, which we have to really look into, and where we are all only looking in for a 99.99% uptime, right, without an accident, without a downtime. So the system failures and the downtimes are really very critical. Connectivity and configuration issues with the field devices are a real big question. And insecure protocols, the data sent in a non-compliant, formats is a major challenge for us. How do we really look into for? And also the challenges of securing the OT networks today is really very huge. When you come on to the cybersecurity aspect of it, there are so many systems which are blind to the devices in the OT network. You really have to know what are the devices which are there. With the IIoT, the sensors coming in, it's really massive and really very difficult to handle that kind of situation. It's you're unable to detect the vulnerabilities. Your complex system integrations and slow threat response times are the major challenge. And also you have from the networking and infrastructure aspect of it, there's no mapping, there's no segmentation. We talk of the zero trust now in due course of time in the OT networks. That's the technology which we need to really follow. But it's most of the OT networks still don't follow that, right? And we're unable to monitor the packet flows and limited device compliances. So these are the kind of challenges what we are facing, with no real-time asset inventory. Just to tell you, assets are the most important factor in any OT network. And if you ask any industry leader or the business leader how many assets you have, he will really fumble. So we need to be really very, very careful of the asset management in OT environment, right? Because their patch management, their configuration management, their other aspects which are there have to be really taken care of. And also the inaccurate tracking, firmware, and the model information has to be there, right? And this is the challenge what we are finding. And there are incomplete vendor and contractor activities, and it's a very costly site visit into the OT network. It's not just like the IT network what we try to do with one machine going down, we get recover it. And the IIoT actually leaves such a huge amount of attack surface area. And it's really huge when you talk of the vulnerabilities in the device memory, your device physical interfaces, your device firmware, your local data storage, your challenges in the backend APIs, your third-party APIs, your vendor backend API. So it's the list goes on and on. This is only the bird's eye view of the challenges what we face when we are trying to secure the IIoT devices. But it's really a point of concern. And the kind of attacks which are there in the IoT, it's again a bigger challenge. Whether it's your physical attack, whether it's a network attack, your software attack, your data attacks, that's all we need to take care of in the IoT. And this is where the security jumps in, because any vulnerability in any of these IoT devices, the IIoT devices, can bring down the complete network. We got to be really very careful. We really have to be very proactive now to find out these vulnerabilities and work on them. So some of the risks which are there, and these are the kind of attacks which are happening right very prominently today. One is the ransomware. Everybody knows about it. Uh, Needless to say, there's so many ransomware attacks on the OT networks. We got to be very careful. How do we protect the OT network? People talk of the air gap between the IT and OT, but with the cyber physical system, it's the most challenging part to take care. You have the supply chain attacks, which we are seeing off late. That's where the attackers or the criminals are really very active. Your remote access attacks, and while we were in COVID, we were not able to get into the SCADA systems, right? How do we really monitor the complete OT network? And we tried to work it out with the remote access, but they had a challenge. They had the vulnerability of it getting attacked while there was a remote access. Even if the system in OT is down, and if you try to give it to your vendor to repair, there's a challenge of attack or into your OT network. And the targeted ICS attack is another challenge. So it's going to be like causes a challenges of the safety, your downtime, your IP theft, your financial loss, your network loss. All those things really happen. And when you look at the cyber physical system impacts which are there, like I told you, it's really huge. There's a challenges of starting from your denial of service to loss of control, to operation shutdown, to the loss of customers, your IP thefts, your environmental impact, your health and personal risk, your damage and destruction of the physical property and equipment. The list is really very long, and the damages are very perturbing. So you cannot lead to a situation where you have the financial loss due to outages, downtime, recoveries taking longer, and the increased and the denied insurances, right? So you have to be very careful on that particular aspect. And securing the cyber physical systems is equally hard, because the vulnerabilities are increasing, like I told you, and I showed you the threat landscape which is there because of the IoT and the attacks in the IIoT and the IoT. So the sensors and the controllers, or more of them, are computers, and they can be programmed for general purpose. And they're all networked, they're remotely accessible, they increase the threat landscape, right? And by necessity, billion of low-cost embedded devices are getting into the network. So we really need to have a secure embedded devices. And we have physically insecure locations. How do we protect them, right? So we are in a situation where any of the smart factories, what are there, like I told you, there's a huge threat landscape. They can be attacked, and these attacks will continue to happen. And deploy the devices which are being deployed over a period of 20 to 30 years, they all give you lots of vulnerabilities altogether. And some of the technical limitations are that it's not really very straightforward as the IT system, and you require a specialized domain knowledge to get into it. You have to have the safety, and the critical OT components cannot be patched like your IT equipment. You need to be very deliberate. You have to elaborate the verification of the patches. You need to validate the patches before you get in. And at the same time, the forensic investigation is very difficult. It's really impossible to do a forensic investigation of OT network. Not very easy to do. And the other challenges you have, generally the outdated operating system, they are out of services, they're out of the support system, and there are incompatible softwares and drivers, and the performance limitations really add on to the complex situation of the cyber threat landscape, right? And this is one of the site, very shortened, and you can just go onto the site and just type in the vulnerable IoT devices all across the world. And if you just put it power plants which are vulnerable, it will give you the IP addresses and the locations and the vulnerabilities of those power plants or the power grids. So that's very simple to know how the attack surface, and this is really increasing, right? And this Jordan.io is a very interesting, engine. Gives you all the details of the vulnerabilities which are there. You can really monitor the network. Like I told you, the supply chain risks are growing, and unconventional, your chain link threats that do not depend on one single attack vector. So we are seeing this, the supply chain that includes tier 2 and tier 3 suppliers, your subcontractors that compromise the security, and they are all there, and you will find that they can be compromised. And the supply chain challenges are especially acute in the OT network and may become worse when you're putting those compromised devices in the complete network. And more importantly, what we are seeing is there's a lack of capability, there's a lack of capacity and the skills. And if you look at the overall digital workforce, what we have, and as compared to the engineering, what we have, the cyber workforce, what we have, the OT cybersecurity workforce is minuscule as compared to that. And this is where we have to be proactive in training people in capacity building for the OT networks. Some of the points which you can implement for the cyber defense strategy. One question which always comes to your mind, that can you secure the OT systems, right? And it's between the risk and the benefits. The answer would be yes, right? And if you're having very convergent infrastructure, you have the right technology, you have the right framework which you're putting in, you are attending to the right risks to the OT, right, network, you can really protect. And this can be achieved by several ways, and in fact there are no silver bullets unless it integrates them, all of them. And you can work on the network security, your vulnerability management programs, your antivirus, your malware platforms, which can be updated and can thwart any cyber attack, take backups, configuration agents, your incident handling integrations, your future forward processes that consider the OT security. So that's how you can really secure your OT network. And you should be able to manage the endpoint security and integrate a variety of hosts and technologies if used safely within the proven OT experience and relevant OT consideration. So you can think of a situation where it is win-win for you to secure the OT networks. And there are certain, OWASP top 10 IoT risks which are there. You can actually go through them. And while designing the system, while implementing any OT network, and while implementing all the IoT devices into the network, take care of these vulnerabilities which are there. And I'm very sure whenever we do these kind of due diligence on the IoT devices, we are able to overcome most of the challenges which I spoke of earlier. And some of the technologies required to reduce the risks which you can put it. One is the asset discovery, asset management, your inventory management, network topology mapping. So that's very important when we talk of the cyber physical system. Your vulnerability management is equally very important. Continuous monitoring with anomaly detection is available with some platform. You can add analytics, you can add AI, automation, and orchestration in the SOC. And you can have it integrated with the IT security tools like SIM, SOAR, XDR. So that's the way forward, so that it's very difficult for the attackers to move laterally, right? And also one point is a zero trust, right? And you can have the micro segmentation which can be implemented in the OT networks. So the security and the operations go hand in hand, where we talk of the threat detection, your vulnerability management, the forensics as part of the cyber security. You can manage the asset tracking, configuration tools, and the audit trails of all the devices which are there in the network, simultaneously. So that really gives you a pretty good picture of how you're working in the OT network and guard you against any cyber threat, right? And more importantly, the asset management is very important. I'm emphasizing on that because it can give you the insight into what you have, what are your crown jewels, your understanding system relationship. You can understand, vulnerabilities. You can find the controls and weaknesses which are there. You can find the misconfiguration, so that it can really, give you a preparedness. It can give you a detection and response of any cyber attack which is going to happen. So you really need to work on the cyber processes, the cyber capacity, the cyber competency, the cyber tools, and the cyber technology. However, there's no 100% cybersecurity. Multi-layered strategy is the key. But then, you have to work on all these areas to secure your cyber physical system, and you can take any cyber attack which comes onto you. And I will really emphasize again on the cybersecurity training, because all organizations which are doing pretty well against the cyber attack, they have a skilled people who are able to thwart any cyber attack coming onto that. So make cybersecurity training as the top level priority. Focus on the incremental efforts. Do not try to change the world overnight, but that's very important. And you have to reward and reinforce positive behaviors and make content engaging and relatable, so that you train the people in the network properly. So before I sign off, a very nice line told by Marty Edward, the former director of US ICS CERT: think like a hacker, but act like an engineer to safeguard your cyber physical system. Thank you very much.